Thank you. You guys don't even know if the talk's going to be good yet. So yeah, what he said, I'm Roy. I'm going to be talking about pair programming, what it is, why it works, what it's good for, and not so good for, and some tips and tricks for when you're doing it, what is the best approach. So I'll talk briefly about what I did for a living, which is I was a software consultant for about a year and a half at a small software consultancy in Iowa. Here I worked with a bunch of different clients all the time, and we had to jump from project to project, client to client, a bunch. And there was one consistent thing across all of these. Well, it was kind of annoying. And the other consistent thing is I pair programmed a lot to get up to speed with the new code base. And this is probably all the experience that most of you will have with pair programming, is getting up to speed in new spots of the code base, things you're not quite sure of. But this experience taught me that pair programming works. I knew this after about a month. I was like, this is effective. I'm not quite sure why yet. And recently, I realized precisely why it works. So I'll be telling you about that as well. So for those of you who don't know what pair programming is, but decided to come to a talk about it anyway, thank you. It's as simple as it sounds, is you have two people programming at the same time behind one computer. One, the driver, the person operating the keyboard, and the other one is the navigator, and they are giving instructions to the driver about what to do. And now I can hear everybody thinking, I see how it goes. You are kind of a lazy developer, and you would like an excuse to have half of your workday be done by somebody else. You are exactly correct. That is the end of the talk, and I'll be fielding questions. No, wait, actually, sorry, there's more. So in order to convince you that it's not quite a not-so-subtle trick by developers to do less work, let's talk very briefly about how our brain works, or, well, how we can think about how our brain works, because talking about how our brain works is very complicated. If there are any neuroscientists in the audience, you are officially not allowed to get mad. There's this old myth of left-brained and right-brained people. Left brains are more creative or more better at this and that, which has been disproven for 25 years. Yet the myth sticks around. People still talk about it, people still refer to it, and that's because it's a useful model to think about the way our brain works. So just for a moment, entertain me while we talk about it in that way. So the left hemisphere. It's not really the hemisphere, but let's talk about it like it's a mode that your brain has. A little brain in your brain. So it is the one that is the linear thinking, complicated problem, verbal one. This one thinks in words. The one that I'm using right now to give this talk to you, and the one that, if you're paying attention, are using to listen to my words and parse them into information in your brain. It's really good at complicated stuff. So I assume all the software developers in here will know the difference between complicated and complex, but complicated is when we do all these things in order, and things have to happen at each step. It's bridge building, rocket launching, these kind of things. It's the presumably, hopefully, one little voice in your head that does all of the steps that need to be done to solve a particular problem. So when you're programming, you will use this to write the code line by line, think about all the things that need to happen to the data or to the whatever. It's not so good at the super complex stuff where one thing affects the other, which affects this, which affects that. It's all a big cloud of complicated stuff or complex stuff. They're different. But, you linguistically use them interchangeably. So that's the left mode. If we can think about that as a linear plot of thoughts, I had this one, this one, this one, this one, this one, and they were in words. We can think of the right mode as more of an abstract cloud of thoughts that we can't really peer into. So this, a lot of people would call their intuition. It's like, well, I know this is true, but I don't know why it's true. My brain is telling me that it's true. It's the inscrutable part of your brain that tells you the name of the actor you couldn't quite think of earlier when you're trying to go to bed. It's like, hey, by the way, that's this guy. This is the part of your brain that considers the problem holistically, all at once, and distinctly asynchronously. So that's why it takes a while to get back with the results, because it doesn't know how long it's going to think about them. It's very suited to complex problems because that's how it thinks, as opposed to complicated problems. Now, the major constraint and major strength of it is that it doesn't operate with words. So the inputs aren't verbal, the outputs aren't verbal. We can't really inspect it. We can't really see what's going on in there. It doesn't process anything verbally. To prove this to you, as an exercise, in your head, close your eyes for a moment, for 5 seconds, describe with words the face of your closest loved one with words. I bet not a lot of good descriptive things were coming out. It was probably like, there have a mouth and eyes. Some things just can't really be processed with words. So that's what this other part of your brain's for. I can hear you thinking already, so I have 2 brains in my brain. So what? I thought this was a talk about pair programming. Some of you may already be seeing where this is going. But the thing about your brain is that if we think about these 2 modes as 2 CPUs, and we have memory somewhere, there is a shared bus. Only one of these CPUs can access this memory at a time. So that's not good. And to illustrate what I mean by this, I'll have 2 examples, one for either one. If you've ever known that you know the answer to a question, but you just have to sit there and search it up through the library, your mind will go completely blank while you're doing this. Your L mode will shut up and let the write mode do its work. And on the opposite side of the coin, you might have been extremely stuck in some complicated problem where you're trawling through every step over and over again, but it just doesn't quite make sense. There's something that you're missing, and it's frustrating you, so you get up, and you go get a coffee, or you go to the bathroom, and then as you're waiting for the coffee machine to pour your coffee, oh, of course, that's what it is. Well, that's your L mode shutting up for a second and letting your R mode get a chance to have at it and give you the answer. So this is like bus contention. They get in each other's way so that when one shuts up, the other one can do some work. So the way that this looks like in programming is when you're working through all the complicated parts, stepping through line by line what needs to happen, it's really hard to consider the holistic picture and to get information about the holistic picture. So the first click for me, this diagram and idea is from Andy Hunt's book of Pragmatic Thinking and Learning. And that's when it clicked for me. When I read this, I was like, oh, of course, that's why pair programming works. This is a really good book, by the way. I would recommend it. But that's why pair programming is more than the sum of its parts, because you get both of these modes kind of working together at the same time. So when you are driving, you want to stay in L mode as much as you can, focusing on the line-by-line logic and not think about the whole picture too much. While the navigator doesn't try to focus on the immediate technical implementation of what task needs to happen. They just kind of think about the whole picture as much as they can. And together, they will make code that is consistently better. So let's get into some of the concrete downsides and then upsides to hopefully convince you that the downsides are worth it. 1 second. Okay. So the primary and obvious cost of pair programming is we have 2 people doing one task that could be done by 1 person. So the cost is double the man hours, give or take. This is valid. This immediate cost is so visible, obvious, and large that it's probably the single reason that everyone isn't always pair programming. Now, how this matters in a talk about you should do it anyway is you shouldn't think of pair programming as a productivity hack. You shouldn't think of it like this is always better. It is an investment strategy. And if you know anything about investing, you know that it's not always worth it to pursue an investment strategy. So that's one of the downsides, is that it's expensive. Source, common sense. Most studies suggest that it's actually slightly slower to complete the same task as a solo developer, or compared to a solo developer. So it's about an increase of about 10% on the task time. Now, there are some studies that say that it's shorter too, but by and large, meta-analysis shows that it's slightly slower. Now, what this means, or well, it's a bunch of different studies, and they don't really consider the fact, none of the studies at least that were analyzed, considered the fact that code review, which if it's part of your process in your studio, takes time as well. And code review, at least at any place I've ever worked that pair programs, you don't have to do code review if you've pair programmed. You can just send it right through, which I would suggest, by the way. So what this means is that actually the time savings are slightly bigger depending on how annoying your code review process is. And it'll increase some metrics too if you have bosses that care about mean time to change, for example. Let's take a look. Finally, a lot of programmers have an initial dislike to the practice. They do it and they don't like it, or they've decided they don't like it before they do it, which is fine for a variety of reasons. But this cited study right there supports the common observation of people like me who try to teach other people to pair program that the graph of liking it is the lowest about half an hour after you start doing it. You're like, this sucks. We're having two people, we don't know how to do it. So but just push through that because study after study shows that the graph goes up and it only goes up. And the more you do it, you become somebody like me who gets up on a stage to tell other people to do it. So it's kind of like a brain worm in that case, in that sense. So that's the downsides, really. Let's talk about the upsides. Increased code quality. I'm sure everybody here would like to have fewer bugs, right? Nobody here wants more bugs, I would imagine. So how much of an increase in code quality? Well, it depends on the complexity of the problem and the experience level of the developers doing it. The pairing, that is. So if you take any random group of programmers and you pair them together and you give them a set of test cases, solo developers will pass those test cases with a certain time limit. They'll pass 75% of the test cases, give or take. Whereas paired programmers will pass around 90. And that's a big difference. In my opinion, it's a big difference. And the more complex the problem, the higher the difference. But code quality-wise, so that's like, different bugs that get solved with the more test cases that you solve. But code quality, correctness, those kind of things, the percentage increases are off the charts, in my opinion. For juniors especially, if you pair two juniors together, meta-analysis shows that across whatever definition of code quality you like, there will be an average of 150% increase in quality. That's quite a lot. That's a lot less bugs on the bug tracker for later. Intermediates, 92%. Interestingly, and worth noting, seniors together, no increase. No statistically significant increase, at least. And that's a big difference. There is a small increase, but it's not, it's not statistically significant, so it doesn't count. So the more complex the problem, the more junior the software developers, the more you should be thinking about pairing together. So that's increased quality. Now, not only does your code base really like it when you pair program, the programmers also really like it when you pair program. Job satisfaction is up majorly, measurably improves team spirit and work satisfaction. Now, correlation does not equal causation. You might have heard of that before. Places that pair program are more likely to have other modern development practices and be willing to try things. And in my opinion, places that have modern development practices and are willing to try things are nicer places to work, generally. So, who knows, right? But if you pair program, you might see an increase in job satisfaction. The biggest one, and you know it's the biggest one because the font's the biggest, and it's the most important. Learning. Oh my God, it's insane for learning. 15 different studies were analyzed in this meta-analysis. Consistently, every single study increases learning across whatever their definition of learning is. Notably, the closer they are, but they can't quite be exactly the same in skill level, learning is increased even more. So if you have somebody who's been programming for, let's say they're an intern, you might want to pair them up with one of your juniors. It will be very good for both of them. So let's get into some concrete advice. Oh, wait. This is my concrete slide. Oops. So from a business perspective, you want to look for opportunities to pair programmers that have small-ish differences in skill, that are close to each other, that won't be talking in super high-level concepts when they're just an intern, for example. So pair people who are kind of close, but not too far. The increase in code quality will save you the man hours you invested down the line. It's an investment. Man hours now, and you get more experienced developers, contenter employees, and less bugs on the bug tracker later, which in turn gives you those hours back. So, some concrete tips for the driver. When your navigator is talking to you and giving you a task, you want, and it's not quite on the level of abstraction you want. So if they are saying to you, I want you to press the P button, and that is annoying you, you should tell them, because otherwise you will fight each other very quickly. So you don't have to tell me to press the P button, just tell me what the function name should be. Or if I'm telling an intern, hey, I want you, or a senior, for example, if I'm telling him, hey, I want you to name this function this way, it's like, don't tell me what to name it, just tell me what it should do. So communicate with each other about what it does, what level of abstraction you want to be talking about task-wise. Now, as the driver, you should ask questions if your intuition or experience tells you that something that your navigator just told you to do doesn't quite make a lot of sense. Like, wait, I thought we always do X before we do Y, or shouldn't we check this variable instead of this one? You are more down to the nitty-gritty implementation levels, so you have more oversight of this kind of thing. So ask questions. When you're solving a problem, this is also for the driver, when you're solving a problem and you're not quite sure how to approach it, and you get an idea as a driver, you're like, oh, I know, we should do it like this. Don't continue driving. You say to the navigator, you take the keyboard. I'll lead us to the solution. And finally, for the driver, trust your navigator. They're zoomed out. They're going to tell you to do some things that might not make immediate sense to you. Trust them. You have less information than them, and that's kind of the point about the setup. So for the navigator, you should give your driver the next thing to do and the highest level of abstraction that we were talking about earlier as you think they can handle. You want to start from the top and work your way down and not the other way around because, it could lead to some bad relations, let's put it that way. If you are giving somebody instructions that they think are obvious, it might make them think that you think they're stupid, make them feel like you're talking down to them. So it's way better to go from highest level of abstraction, hey, let's write a class that represents this idea, and then if they don't immediately do it, go down a level. So, okay, well, go to create this file, if that makes sense. It's way better to do it that way instead of starting with go create this file and then tell them why, because it gives them some autonomy as well, and then you're not really just programming by yourself, but through them, which you don't want to do. You want to pay attention to what they're doing. You're supposed to keep them heading in the direction that you intended. So you're thinking about the whole picture, but you're still with them in the moment, paying attention to what is going on. Like the same way if you were a navigator for a rally car and you were reading the map, you still want to look at the steering wheel of the driver, that you're not going down the wrong road and be like, hey, actually, we needed to go over there. Now, finally, you need to tend the to-do list. So you need to keep all of the individual tasks that still need doing to achieve the greater whole in order. You need to keep that list in your head or on paper. I like on paper. And you need to decide what the best order to do them in is. And then your driver needs to trust you on that. So that's my concrete advice. I have a resource that you should Google. It's more like an idea. Strong style pairing. You should Google that. The QR code is from my LinkedIn. It's not for the Google to let me Google that for you, strong style pairing, although that would have been funny. Maybe I should have done that instead. Yeah, I suggest you Google that because there's a lot of resources on the subject. And I really believe in this style of pairing. I've tried several different ones. And I think this one addresses all my concerns that I had. So there's a lot of good research out there. So that was my talk. We got some time for questions, I think.
Yeah. Great. Any questions?
Thank you.
Let's go first. There you go.
Yeah, I'm still kind of a little, not lost, but a little curious about the driver navigator structure. Like, does the navigator then just only plan out how you would solve it, and the driver actually just comes up with a code for it? Or
So it kind of depends. 2 days ago, me and Julian over there, we were pairing, and I tell him, hey, we need to do this. And sometimes I have an idea for implementation. I said, let's do it this way, because it'll be relevant down the line that we do it in a specific way. And sometimes I tell him, oh, well, we need to achieve this goal. Like, we need to change this here, or we need to get this piece of data from somewhere higher in the structure down. And if I don't have an implementation idea, I just pitch, like, here's the task we need to do. And then he spins his wheels on it for a second. I spin my wheels on it for a second. And then one of us will come up with the way to implement it. This is kind of like why I believe it's about the same speed, or you can even get faster the more you do it. Because you kind of, I'm sure when you're programming, very often you're typing and you're typing and you're typing. And then you're like, how do I want to do this? That how do I want to do this time is cut down by a lot because you have two people thinking about the exact same thing. So yeah, does that make sense?
yeah, okay, thank you.
Awesome.
Maybe just a quick practical question. You said that oftentimes you want to switch between the driver and the navigator. Obviously, you can easily hot swap when they're sitting next to each other, but do you have some practical advice for when you do it online? Like, do you just commit and then
Exactly.
move over?
Yeah, we usually worked on a branch and then just committed, and then there's tools as well. There's one called, if you search for mob programming Git tool, there's one where you can just type literally mob pass, and that'll just pass it on to the next guy. It'll pull the branch over there, and it's super cool. But yeah, no, usually you just commit and you push, and then you have them pull. So like the switching time is like 2 or 3 minutes. Okay. But yeah, you could do it on task, or you can set a timer for like 2 hours or something.
Okay.
Yep.
Yeah, just quickly building on that, how dynamic is this switching around? So is it always like people are set in their own roles and then they sometimes switch, or is it something that happens more often?
No, so the way that it happens usually, in my experience, is like me and a coworker will be looking at the tickets to pick up in the morning at stand-up. It's like, oh, well, we got to do this. I don't have anything to do. Oh, well, Mark, you don't have anything to do either. You want to pair on this? And then we read the ticket together, and then, oh, well, I have an idea for how we should fix this. So that means I navigate first, and he drives.
Last question.
Hi, do you have any thoughts on how your insights on pair programming translate to programming with like a large language model with AI?
Yes, I have a lot of thoughts. I have a lot of thoughts. In short, I like to base my opinions on evidence, and right now, all of the evidence is pointing to large language models affecting all of the same statistics that pair programming do, except in a negative manner. So where you would see an increase in code quality, you see a substantial decrease in code quality. Where you would see an increase in job satisfaction, you see an increase in job dissatisfaction. Where you see an increase in skill, you see a decrease in skill. So yeah, I think like I have a lot of thoughts. I think that's how I'll sum them up, is like empirically, there is no evidence suggesting that it works like that at all. In fact, the studies show that it's the opposite.